Hi all, very good evening and welcome to the fifth week of the live sessions for Artificial Intelligence, Knowledge Representation and Reasoning. So, can you just confirm whether I'm audible and is my screen visible?
Yes, sir.
Okay, thanks all with it. So, without further ado, let's get started. So, today we'll be discussing some questions related to week 6 content of the course, and that is basically the initial some introduction to prologue and horn clauses and so on and so forth. Okay, so let's go to the first question. This is the first question in front of you. So we have to select the correct statement about horn clauses among the 5 options that are given to us. Yeah. Good evening, Vipul. I'll create a poll for this question and then you can share your votes over there and then we can discuss which all options are correct or incorrect. Just give me a moment. Okay, so I have launched the poll. You can share your thoughts over there, or you can write in the chat as well, and then we can discuss. I'll give you a couple of moments to go through the options. So we have a couple of votes. There's one vote for option C, D, and E, and there's another vote for all options. Okay. So, okay, let's discuss the options. So if you remember from the lectures, right? I hope you can see the screen. Okay. We have another vote for none. Okay. Okay, so if you remember from the lectures that a horn clause is a clause with at most one positive literal. Okay, so the key points to notice here is that first of all it's a clause. Okay, and second of all there has to be at most one positive literal. Okay, an example is shown over here. So this is basically a or of several literals or a negation of literal, right? And there's only one positive literal P over here. All other literals are negations. So if we go back to the options that were given to us,
Sir, your voice is not really very
is it
clear.
better now?
Yes, yes, it's
Okay,
better now.
the
Yes, sir.
mic must have shifted away. Sorry about that. Okay, so I'll just repeat what I said just for the sake of clarity. So basically, horn clauses, if we remember from the lectures, is a clause with at most one positive literal, right? So the two things to notice here is that it's a clause and there is at most one positive literal, right? So this is an example, right? So this is a or of several literals or negation of literal, and there is only one positive literal, which is T over here, and all others are negations or negative, right? So with that in mind, if we look at the options, option A can't be correct, right? Because it's written that it's a conjunction, and conjunction means and, right? But here we saw that a clause has to be a disjunction. Do you agree with me?
Yes, sir.
Yeah.
Yes, sir.
So the first two options are nullified because it can't be a conjunction. Option C is correct because it is a disjunction of literals with at most one positive literal and zero or more negative literals, right? And horn clauses satisfy the definition of a clause in a CNF formula. Of course, they will because they are clauses after all. They are a subset of the whole set of clauses. So they will satisfy that condition, and option D is also correct. And option E, horn clauses, when written as a logical implication, have a head and a body, where the head has at most one positive literal and the body is a conjunction of zero or more positive literals, right? So this is like the prologue notation, you could say in a way, and this is also correct. So the correct options are C, D, and E. So this is just a basic recall question from the lectures, just based on the definition of horn clauses. So I hope uh, this was clear. If there are any doubts, do let me know. Thanks for the thumbs up, Somil. Okay, so I'll move ahead. If there are any doubts, just let me know. Okay, here's the second question. So continuing our discussion on horn clauses, so this question asks us which of the following can be expressed as a set of horn clauses. Okay, and the hint is that you can use the rules of substitution to convert these to clause form. Okay, so you might have to work it out a bit. If you have a pen and paper around, you can solve it right now. You basically have to just simplify it, right? And see which of the following options actually do satisfy the condition of being expressed as horn clauses. Okay, I'll once again create a poll. Okay, so I have created the poll and we already have one vote for options A and B. Okay, what about C and D? Okay, we have another vote for option A, B, and C. I'll give you a couple of minutes to go through all the options thoroughly and then we can discuss the solution. Okay, I'll give you a minute. Alright, so we have another vote in the chat for options A, B, and C by Arkudeep. So, okay, let's discuss the options one by one. Alright, let's consider option 1 first, option A. So basically what is given to us is for all x, teen x, or not or, and there exists y such that owns xy and apple y implies happy x. Okay, so this is a bit of a complicated thing that is given to us, so we have to simplify it. And what we'll do first is we'll open this implication. Okay, we'll use p implies q, can be written as not p or q, and that's what we are doing over here. So if you see, there's a bracket, this is the whole bracket to the left of implication, right? So when we open the implication, this will become not of this whole thing. That is what is being done over here. Alright, so we open the implication, we have not of teen x and there exists y and so on and so forth. And now we'll move this negation inside this third bracket. Okay, so we moved it inside, we have not of teen x, this and becomes an or. Okay, and then we have not of there exists y such that this whole thing, this is another bracket, right? Next what we'll do is we'll simplify this particular not operator, we'll push it further inside. So when we do that, this there exists will become for all, right? Because not of there exists something, this becomes for all y, and the negation is transferred inside. So that is what is happening over here. We made this for all y and the negation goes inside, and we have not of owns xy and apple y. And in the next step, we'll again may move this negation further inside, and this and will be converted to an or, and these will have negation. So you will have not of teen x or for all y, not of owns xy or not of apple y. Okay, and this remains, the happy x remains as it is on the right side of them of this or operator. Next we move the for all to the leftmost part. Okay, that is what we are doing over here, for all x for all y, and this whole thing becomes just a or of several things, right? So we have for all x for all y, not of teen x or not of owns xy or not of apple y or happy x, and this is in the horn clause form, right? Because what you have over here is a disjunction first of all, because we have these or operators and there's only at most one positive literal and all others are negative, right? So option A is the correct option. Do you agree with me?
Yes, sir.
Okay, great. So by the same logic, let's do the steps for option B as well. Maybe I'll use a different color. So here we are given something similar. First we'll simplify this implication, and that makes a not of, so we have a not over here, and then this whole bracket is there, and then to the right we have happy or not attentive. Okay, and this part is very similar to the one that we saw in option A, right? So if you follow the same steps of derivation, you'll arrive at a form that will be very similar to option A. You'll have this extra not attentive x at the very end. Okay, this is the only difference in option A and B. And is it Is it still in a horn clause form or is it not? What do you think?
It's still in the on clause form, sir, because happy is
Yeah,
positive.
that's right. Thanks, Somil. So it is still in the horn clause form, as Somil said, because we have at most one positive literal and all others are negative, right? So option B is also correct. Option A is also correct. Let's have a look at option C now. Okay. So now here we have again the same thing on the left of the implication, but on the right we have happy X and proud X. Okay, remember here we had happy or something. Here we have happy and proud X. So let's see what happens. So again we simplify this implication first. We have a not here, the whole thing, or of another thing, and then we, wait, it's getting a bit clumsy, let me erase it. Yeah, okay. Again we simplify this negation by pushing it inside. So we have not of t x or not of there exists y owns xy, so on and so forth. The left hand side part proceeds as we did for options A and B. The difference occurs in this step. Okay, so till this step what we did for options A and B still remains for the left part. So we have not of teen x or not of owns xy or not of apple y or this whole thing, right? Next what we do is we simplify this. Okay, how do we simplify this is basically, so we use this not of teen x or not of owns xy, so on and so forth, or happy x, and this and remains in the middle, and this whole thing goes with happy x in one part and proud x in another part, right? So it's clear until this point.
Yes, sir.
Okay,
Yes.
okay. So now let's look at the two components that we have. So we have two components. One is this for all x, for all y, and this whole thing, and then for all u, for all v, this thing. Okay, which is just basically replacing x and y with u and v for our convenience. Also, so that we don't get confused with x and y. And is it still in horn clause form or not? What do you think?
So the conjunction in between is confusing.
Yes.
So does it still is? That's the most
So
confusing.
the thing here is that these two components that you have, these individually satisfy the horn clause form, right? If we just look at these, yeah.
Yes, yes, yes.
So because of that, we can say that it is still a horn clause form because these two individual components that are separated by this and, these are individually horn clauses. Yeah.
Okay, sir.
So this, so option C is also correct. Uh, when we go to option D, I'm not going through the whole steps over here. You can verify this yourself later on. But here we will see that we have negation, 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 but we have two positive things over here. Okay, that is against the form of horn clauses. So option D will be incorrect. Okay, so the correct options are A, B, and C, as many of you voted for and pointed out in the chat as well. So I hope that was clear. Any doubts about this question? Um, Thanks for the thumbs up again, Somil. All right, so I hope there are no doubts. If there are, do let me know. We can discuss this once more. But for now, let's move on to the third question. Now we are entering the prologue territory. Okay, so question 3 says that each option below, so you're given 4 options. Each option has a pair of predicates expressed in SWI prologue. Okay, and we have to identify which pairs are unifiable, and then we can use prologue to investigate term unification. So first, let's try to solve it manually, and then we can use prologue and see if which of these options are actually correct. We can verify this using prologue. So first I'll launch a poll, and then you can share your thoughts over there about which of these options are correct, and then we'll shift to the prologue interface. Alright, so I've launched the poll, and you can share your thoughts over there about which of these do you think, which of these pairs are unifiable. So remember the unification algorithm from the lectures, and you can answer accordingly. I'll give you a moment to go through the options. We already have one vote for options B and D. What about the others? What do you think? What about options A and C? Okay, there is another vote for options. Sorry about that. So yeah, let's get back to the question. Okay, so would anyone like to share why they think options A, B, C, or D are correct or incorrect?
So the B option is correct because there are two terms and we can means prolog can equate those two terms to be like it can assign x value of
That's
star.
right. I agree with that. Thanks for the contribution, Soumya. Anyone else also wants to volunteer for the other options, maybe?
So in option C and D, is it 2 into
Yeah,
3,
it's
right?
2 into 3.
Uh, I think it won't be resolved because prolog doesn't do this arithmetic. It needs to first assign and then uh, do some
Okay,
operation.
so let's see. Let's experiment with prologue and let's see what happens. So, by the way, do most of you or all of you have prologue installed in your systems already, or uh, have you been facing any difficulties with the installation process?
I have it
That's
installed.
great. Others? So if you don't have Prolog installed, you can do it maybe right now or even later after this meeting, whenever you're free. So when you go to the quiz option for this current assignment, current week, you'll see that you have been provided a link from where you can download the extension file for whichever system you use, and you can install it in your system. Okay, so for now, let's shift to Prolog. Okay, give me a moment. I'll have to reshare my screen. Is my screen visible? There must be a mirroring right now, but
Yes,
okay.
sir. It's
Is the prologue screen visible to all of you? Okay,
yes.
that's great. So this is the prologue interface. So let's look at the options that we had. So the first option we had was P Sun and then P star Earth. Okay, so let's see whether this can be unified. So let me just type this out. Okay, and let's see what prologue outputs. Okay, what did I enter? Did I enter something incorrect?
So there should be one more bracket.
Okay. Sorry about that. So we see that prologue is false, right? Which makes sense because these two are kind of, you could say, constants, and they can be equated or unified only when they are exactly the same, right? As for the second option, we had an x over here, if I remember right.
Yes, sir.
So when we do that and we press enter, prologue returns substitution where we substitute this variable x for star earth. Okay, so that makes sense. All right, let's do it for the third option. Okay, I'm not going to type it out. I'll just copy paste it. You can already see the output that we are going to get, but let's still verify it. Okay, so this is false because we can't unify this. Okay, uh, the reason for that, I will encourage you to go back to the unification algorithm and try to find it out yourself, or it might become clear when you see the fourth option anyway. Let's do that. Okay, so here we have the substitutions given to us. So if we compare the left hand side and the right hand side, okay, here we have substituted x for 1. Okay, so this is 1 here and x here. Then to the right of the plus we have y, which is equal to 2 into 3. Okay, and then for z we have f of something. Okay, f of u into v, so that the prologue system has substituted as f of 2 into 3, and by that logic y is also 2 into 3. Okay, u is 2 and v is 3. Okay, so this is a true assignment, right? This works. So based on this, which of the options do you think are correct based on the prologue experiment that we just did?
The B and D.
Yeah, that's right. Options B and D are correct. Okay, so any doubts about this question?
Sir, I didn't really got why C is not unifiable. Can you please explain?
Okay, sure. So if we see over here, okay, x plus y, we can do that. Okay, okay, let me shift to the Jamboard. Let me stop sharing the whole screen. Give me a moment. Okay, so if we look at this thing, okay, Suppose we substitute this as x equals to 1, like in the fourth option. Let's substitute y equals to 2 into 3 again. Okay. Let's substitute fz and y. Okay, just for the sake of it. Y equals to fz. But when we come to this substitution, we get z equals to y into 4. Okay, so you see the cyclic relation over here. We are defining y using fz and then z using y, which is not possible, right?
Yes, sir. Yes, sir. Okay. I
Yeah.
got it now.
And here we have no such confusion. So option D is correct. So that is one way to explain the options over here. And the simpler way is, of course, to just use Prolog and see which of the options are correct, right? Which is easy way out, but it's better to also understand. So thanks for that, Arkoti. Okay, so should we move ahead to the next question? Okay, thanks, Somil. All right, so here we have question 4. So the Prolog program given on this side, this right side, defines natural numbers using 0 and a successor function, and we have defined 3 versions of this less than predicate. Okay, so you have less than 1, less than 2, and less than 3, where the less than operation has been defined in 3 different ways. Okay, so we have to assume that all the predicates take only natural numbers defined by nat. Okay, this nat definition that of natural numbers that we are supplying to the Prolog system, and based on this we have to answer the questions. Okay, and the first question is choose the correct option, and here we basically have to identify which of these definitions of less than among less than 1, 2 and 3 are the correct definitions. Okay, so firstly I'll just let you go through this program over here, let you think about it yourself, and then we'll explore using Prolog once again, and we'll also first try to explore it manually and then we'll go to Prolog. Okay. Okay, so I'll give you a moment to go through the program and the options. Okay, so I've launched a poll as well, where you can share your thoughts over there as well. And one hint that you can get from the poll options is that only one of these options is correct. Okay, so I'll give you that hint and give you some more time to figure it out. Okay, so we have one vote for option D. It says less than 2 and less than 3 are both correct definitions. What about the others? What do you think? Remember this colon followed by a dash in prologue, right? This is basically seen as an if, okay? Remember from the lectures, professor also pointed out that when we say, let's take the example of the NAT operator that we have defined, or the NAT statement. So we have the first line says that NAT 0, which basically says that 0 is a natural number as per our definition. And then we say that successor of x is a natural number if x is a natural number. Okay, so we have another vote for option C and another vote for option E. Okay, so C says that only less than 3 is correct, and option E says that all 3 are correct definitions. Okay, let's now look at the options one by one. Okay, so what we can do is we can write this program in prologue, run it up, and then check for these two questions. Okay, we can check whether 1 is less than 2 and whether 2 is less than 1, and we can see what each of these less than definitions that we have defined are outputting, and based on that we can infer whether these are correct or incorrect. Okay, but before that, let's explore on our own and try to understand. Okay, so if we consider the third definition of less than that we have defined, so we say that less than 3 0 comma sy. Okay, so it basically says that 0 is less than everything, which makes sense because we are defining the natural numbers in such a way that 0 is the starting point and then we move on to 1 2 3 and so on and so forth, right? So this makes sense, and this is common for all the less than definitions. So the first line of each less than does make sense. Do you agree with me? Okay,
Yes, sir.
let's consider the second line of the third definition first. So this definition says that successor of x is less than successor of y if x is less than y. Okay, so let's consider an example. Let's say this only. Okay, suppose x is 1 and y is 2 and 1 is less than 2, that we know. Okay, so if this is true, which we know is true, then successor of x, which is 2, right, would be less than successor of y, which is 3. Does this make sense?
Yes,
Okay, so we can see that option, the third definition seems correct. Okay, as of now, option C, uh, not option C, the third definition seems correct. Let's look at the other definitions. Let's consider the second one now. Again, let's say x is 1, y is 2, v, and this is 1 is less than 2, which is true. 1 is less than successor of y, which is 3. Okay, this seems to make sense. Let's take the other option, other case now, which is 2 less than 1. Okay, if 2 is less than 1, 2 as per this definition is less than 2, but this does not make sense, right? Do you agree with me?
Yes. Yes.
yes, sir.
Okay, so as of now the second definition also seems to be slightly incorrect. Let's look at the first definition now. Okay, here we are said that we are told that again let's consider, okay, let's consider sx to be 1 and y to be 2. Okay, so x will be less than y. X will basically be 0 less than y if 1 is less than 2. Okay, seems to make sense until now. Let's consider the other option, 2 and 1. Okay, so x will basically be 1 and this will be 1. Again, this doesn't seem to make sense, right?
Yes.
So this is one kind of an interpretation or one way to see. Uh, there might be other ways that you could explore and see for yourself why uh, these options may or may not be correct or incorrect. But for now, let's shift to prologue and see whether this does make sense. Okay. Once again, give me a moment. I'll share my entire screen. Okay. Is it visible? Okay.
Yes.
So when you want to write a program in Prolog, you can use this new option, okay, to open a file, and then you can type in your program over there and you can save it up. Okay, so I've already saved it, so I'm not going through the process of writing the whole thing again. After you have written the program, what you can do is you can use this consult option, or you can even type in consult and the name of your program, whichever way you want to use. Let's do this consult first. Just give it a moment. Yeah. So this is the fourth question, right? So let's select. So the extension will be .pl. Okay. So let's consult this, and it is giving some warnings. Let's ignore the warnings for now. Okay. So we have, you could say in a way, consulted the program, and now let's input these options that we want to check. Okay. So first, let's check whether 1 is less than 2 based on the first definition. Okay. Or let's check the third definition first because we proceeded in that way. So let's check the third definition first. So it outputs true. Okay. Let's check the other case. So here we are checking whether 2 is less than 1. It outputs false. Okay. So this seems to make sense. Any confusion up till this point?
No.
Now let's consider the second definition. And let's check whether 1 is less than 2. Okay. Okay, so this output false for this 1 is less than 2, which is a faulty answer, right? Because we know that 1 is less than 2 and it is outputting false. So there seems to be some kind of mistake. Let's check the second answer on the second case where we want to ask whether 2 is less than 1. So here it outputs false, which makes sense. But the first case it failed to satisfy. So there is some fault with this definition, right? So we can say that less than 2 is wrong. Do you agree with me? Any issue?
Agreed.
Okay. So let's check the first definition now. And we want to check whether 1 is less than 2. Let's see what happens over here. Okay, so it's not outputting something immediately, it's taking some time. Which might indicate that it might have been going into a infinite loop kind of thing. Okay, let's wait for some time and see whether it does output something.
Infinite loop.
Yeah, it has gone into an infinite loop. So now it ended its execution and it told us that stack limit exceeded, which basically means that it went into an infinite loop and it consumed all the memory that it could consume. Okay, so again, there is something wrong with this definition. Let's check the other case also, just for the sake of it. Again, it's taking some time and the output will be same. Okay, it will again show stack limit exceeded. So this is going into an infinite loop, right? So based on that, which option do you think will be correct?
Only C.
Only C. That's right. I'll just stop presenting. All right. So the correct answer is only the third definition is correct. All right. So thanks for the thumbs up, Somil. Any doubts about this question? Anyone?
No, but I do want to ask, can I install Preload for Linux?
Sorry, Vinny. Can you come again?
Can I install Preload for Linux?
You're
I
asking
think
whether you can install Prolog on Linux or Mac. Yeah,
yeah,
yeah. There is an
yes.
option to install it on Mac, which is given in the website that is given to you in the assignment itself. The link that is given to you. As for Linux, you can do that. There is a certain set of steps. If you just Google it, installing Prolog in Linux, you'll get the exact commands to install it. Okay, it can be done.
Okay, thank you.
Yeah, I don't exactly remember the commands right now, so I can't help you right now, but you'll find it. It's quite easily available.
Okay, thank you.
All right. So if there's no confusion, that we can move on to the next question, right? Everyone agrees?
Yes.
Thanks, Vinny. Thanks, Omil, once again. All right, let's move to the fifth question. So here we are given again a different program. So we are given four predicates, P, Q, R, and S, and we have to study these and answer the questions accordingly. So here we are told we have to select the predicate that defines the length of list L as a number n. Okay, so suppose if we output a list, so you can see the input is L and N, right? So L is the list and N is the number. So if suppose we input a list of length 4, then this predicate or this program should output, uh, or if we use the appropriate predicate, it should output 4. Okay, that is the idea behind this question. So I'll once again let you go through the options and see for yourself which of these predicates P, Q, R, or S could be the one that we want. That is the one that defines the length of a list L as a number n. And I'll also launch a poll and then we can discuss it. Okay, so I have launched the poll. Once you are convinced about your about which of the options you think is correct, you can share that through the polls, or you can also write it out in the chat. Okay, so anyone, what do you think? Which of these could be correct? Okay, we have one vote for option C, which says that predicate R is the one that defines the length of list as a number n. Okay, think of it as in maybe take a small example in your mind and try to solve it using the predicates that are given to you. Okay, let's take a list. Let's say 10, 20, 30, 40. Okay, so think about it. If this list is something that you input into this definitions, will you be getting 4 as the output? Okay, we have another vote for option D. Remember this format that is given to you, this third bracket H, then a bar, and then T, another third bracket closing. So this is basically a way to denote the list where H indicates the head or the first element, okay, and T denotes the tail, which is the rest of the elements after the head. Okay, so if you had a list like 10, 20, 20, 30, 40, so your H would be basically 10, and then T would be 20, 30, 40. Okay, and this colon and dash again represents if. Okay, so if we look at, let's say, the first predicate, let's consider E. Okay, so the first line of this definition says that if we have an empty list, then the output is 0. Okay, so does this make sense?
Yes.
Yes.
Oh, thanks, Vinny. This does make sense, right? Because if we have an empty list, then the length would be 0. Let's look at the second line of this P definition. Okay, this tells us that if we have a list in the form of heads and then tails, where heads is basically the first element and tails is the rest of the list, then n is the length of the list if p t comma m. Okay, where t is the tail, which is the rest of the list, m is the length of this tail of the list or t, and n is m plus 1. which is basically the length of the tail plus 1. So does this seem to make sense?
Yes.
Okay, thanks Naresh. Maybe I'll write it out once for you. Okay, was there a message in the chat? Okay, there wasn't. Okay, let me just shift to the Jamboard. Alright, so we have a list like 10, 20, 30, 40. Okay, and this P definition tells us that the length of this is n if P. Okay, so this is the head basically. This 10 is the head, and this whole thing is the tail. Okay, so this length is n if 20, 30, 40. This list or this sublist has length m and n is m plus 1. Okay, so if we recursively try to define this for this part, what will we have? P of 20, 30, 40 is m if 30, 40. This length is something else, let's say x, and m is x plus 1.
Explain.
Right. And similarly, then we will have something again if we recursively go one more step, which is p of 40 is, let's say, y, and sorry about that, x is y plus 1. And if we go one more step deep, what we'll have is p of empty something is something. And this goes back to the base case that you had given, right? The length of an empty list is 0, right? And this y would then be 0 plus 1, right? This will become 0 plus 1 or 1. And since y is 1, x will become 1 plus 1, 2. Since x is 2, m will become 3 and n will become 4. Okay, so this does seem to output 4, which is the length of the list. But is this explanation clear? Any doubts about this explanation?
No, but in the next option, it says m is equal to n plus 1. What is the difference between m is n plus 1 and m is equal to n plus 1?
Vineet, your voice seems to be breaking a lot, but I guess you were asking about the second option, which defines it as n equal to m plus 1 and not n is m plus 1. Is that what you were asking?
Yes, yes.
Thank you for that. Uh, but is this part clear? Any confusion about this part?
No confusion.
Okay. Yeah. So as Vineet rightly pointed out, the second option tells us the only difference between the definitions of P and Q is that we define in P n is m plus 1 and in Q we define as n equals m plus 1. Okay, so this is a bit of a technicality of programming that is coming over here. Okay, so how many of you have some familiarity with some programming language? Okay, Somil has, Vineet has. I remember, yeah, Argodeep also has some experience. Okay, thanks, guys. You can put down your hands now. So usually the equal to operator, right, is is used for assigning something, okay, in programming. And when we have to equate something, we use some different symbol, right? So if I have to give you an example of let me use another page. Okay, so if I had to give you example of, let's say, Python, which is a programming language. Okay, so if you write x equal to 2, this would mean that you are assigning x the value of 2. And if you had to compare x with 2, you would write x equals 2. Okay, so this will output a true or false. Okay, but this was an example with Python. Uh, the concept is more or less same. So here when you are defining this length as n equals to m plus 1, what you're doing is you're not assigning, you're not equating this, right? You're assigning as n as something. So the issue that you will arise, that will arise over here is if we just write down the recursive equation that we had arrived at, m is x plus 1, x is y plus 1, and y is 0. That's what we came to, right? Yeah. So the problem that we'll arrive at here is that this will be assigned this value, right? So you'll get an output that will be something like 0 plus 0 plus 0 plus 1, which is not what you want. You want the value 4. Okay, so when we use Prolog, you'll see that the difference that is occurring by the definitions of P and Q. Okay, so does that slightly help your confusion, Vineet? Uh, Vineet, your voice seems to be breaking. Maybe you can type it out in the chat, what you're trying to say. Okay. Let's uh, try to solve it at Prolog, and maybe then after that it'll get a bit clearer. Okay. Okay. But as for options, as for the predicates R and S, uh, would anyone like to say whether they can be correct or not? Anyone? Yeah, thanks, Vinny. They will be wrong because you are defining this as n is m plus h, right? So basically you're adding the head element, right? So that would add, if the head is 10, that would add 10. No, that's fine if they depend on the first element, but you will be keeping on adding the elements itself, not the length of the list, right? So you're adding plus one, right? That is adding 1 to the list, but here you're keeping on adding the element itself. So you'll get 10 plus 20 plus something and something, right? So that won't be the length of the list. So both R and S would be incorrect. But now let's shift to Prolog and see if we can resolve the query that, the doubt that you had raised beneath. Okay, give me a moment. I'll share my screen. All right. Let me go down so that we have some space. Let's consult the file. Okay, again we have some warning. Let's ignore these warnings. And let's try to see if we get the correct answer. Okay. And let's input a list first, the same list that we were trying to examine. Okay. And n is the length of the list that we want. So this outputs n equals 4. Okay, so this seems to make sense. Let's replace this with q. Okay, okay. So I was slightly wrong. Maybe that's what was creating the confusion for you, Vinit. So the output that we got is 0 plus 1 plus 1 plus 1, which does evaluate to 4, but that is not exactly in the format that we want, right? It's not the length that is being outputted to us. So if I just shift back to the Jamboard where I was explaining this, so what will happen is we will find out that y is 0, right? Y will be equated to 0 because that is an empty list, and then x will become 0 plus 1, right? And then m will become 0 plus 1 plus 1, right? Okay, maybe I've gone down a bit. And then m will become 0 plus 1 plus 1, and then n will become 0 plus 1 plus 1 plus 1, which is the final output that we got as per Prolog, not 4. So does it slightly help now, Vineet? Is it a bit clearer? Okay, uh, that's great. So let's quickly check the other options as well, if that is clear. Let's see R. So what R outputted was 100. And does anyone see where this 100 is coming from? So what R is basically doing is it's giving us 10 plus 20 plus 30 plus 40.
Adding all the
Yeah,
elements.
exactly.
Yes.
So this will equal to 100. Okay. That is what R is giving us, but that is not what we want in the question. Let's check S also. Okay. S is also giving us 40 plus 30 plus 20 plus 10 in the same format that Q gave, because here also in the definition of Q, in the definition of S, we have used an equals operation instead of this is. Okay. So when you have to uh, this is the is the operator is the way to go when you have to calculate something or assign something forever, right? So when you want to assign n is m plus 1, and if m is 3, n will be assigned 4, not 3 plus 1, which seems a bit confusing, but uh, if you are familiar with programming, it will make sense eventually. Anyway, even if you're not familiar with programming, it's fine, you'll get the hang of it. Okay, so based on these, which option do you think would be correct?
So B is correct.
Is B correct or is A correct?
Uh, A correct. I was saying the B. Uh, PL
Ah,
comma.
yeah, that's right. Uh, so yeah, option A is correct. PL comma. That's right. Let me just quickly shift back to the normal presenting mode. All right. So thanks also Vineet for answering in the chat, and thanks. Was it Somil? I couldn't see your name because of the screen sharing process.
Yeah,
Okay.
no problem, sir. So it was me. So I have a question. So here in if we take the R, so it gives the sum of elements
Yeah.
of the list. If
Yeah.
we can say that, yeah. So sir, does Prolog take into consideration, I mean, hybrid elements like a string, a character, something
Uh,
like that, as a
we could try that and see what happens. Uh, Even I am a bit rusty with Prolog, so let me just quickly check and see what happens. Okay, so the list I'm outputting is 10, comma A, comma B, comma 20.
okay?
Okay, so this still outputs 4. Oh, P outputs 4. That's you were asking about predicate R, right?
Yes, sir.
Yeah,
Yes.
so it's running into an error. So evidently it doesn't take in hybrid elements. It only takes in numerals. Yeah,
Okay.
because we are adding it up. Maybe there might be some way to maybe use some kind of an ASCII value of those characters, but we'll have to go into some details of Prolog programming for that. Okay, I'm not sure about that. Yeah.
Yeah, no problem, sir. Just wanted to
Okay,
try it
sure,
out.
sure.
Thanks.
That's nice actually. Thanks for asking that, Somil. Okay, so yeah, that was a nice suggestion by Somil, and the rest of you also. You can explore different things in Prolog on your own and see what works and what doesn't work. And that's actually the best way to learn any programming language if you're into that. Okay, so I hope question 5 was clear. Shall we move on to the next question? Okay, let's move on to the next question, which we kind of did already solve. So just for the sake of saying the answer, what do you think would be the answer in this question? So basically it's the same setting, the same program, and we are asked which predicate defines the sum of the elements in the list as a number n.
Option C is
Yeah, option C is the correct answer, which is predicate R, which we just solved. Okay, any doubts? Anyone else about this particular question? Okay, that's great. If there are no doubts, let's move on to the next few questions. So questions 7 to 11 will be based on this program that it's shown over here. Okay, so I'll just briefly go through the program, and I'll also let you take in the program and go through all the lines. So basically what we are told is we have a predicate same as a comma b, which is basically whether lists a and b are same or equal. Okay, for example, if we take something like 1 2 c d 5, so these two lists are exactly same, right? So the same as should output true. Okay, that is what we want to define. Prefix of a comma b. Okay, so this checks for whether a is a prefix of b. Okay, so again an example. So 1 comma 2 is a prefix of this bigger list, which is 1 comma 2 comma c comma d comma 5. Okay, so 1 comma 2 is a prefix, which means that it is a part of the initial some segment of the list that is given to us. Okay, that is how a prefix is defined. And so if we enter this should output true. Then suffix of a comma b, this says that d comma 5 is a suffix of this bigger list. Okay, which basically means that it is occurring at the last or the latest segment of the list. Okay, so the other predicate sublist A comma B. This basically checks whether list A is contained in list B as a contiguous block. Okay, so if we take an example, this 2 comma C is there in the middle of this bigger list, right? So we have 1 comma 2 comma C comma D comma 5 and 2 comma C is there in the middle. So again, this sublist predicate, if we input these particular things, it should output true. And the last predicate subsequence is to check whether the elements in list A are contained in the list B, but these may or may not be contiguous. Okay, but the relative order has to be maintained. Okay, so for example, if we take this 2 comma D, okay, so 2 is appearing in this bigger list, and then after some elements D is also appearing, right? So this, we can say this 2 comma D is a subsequence of the bigger list, not a sublist, a subsequence. Okay, so this is what we want to define in our program, these definitions of same as, prefix of, suffix of, sublist and subsequence. So is the setting clear until this point? Okay, thanks once again. And we are to basically fill in the blanks. Okay, so we are given these number of lines 1 to 11, and we have to fill it in with appropriate uh, segments or appropriate whatever we want to write definitions, such that these things that we want that we defined in the top are satisfied, or this is what the program does whenever we output any kind of list to it. Okay, so what you can do is, if you have a mobile somewhere lying around, you can maybe take a screenshot of this particular page, and then we'll move on to the questions that are based on this segment or this data, you could say. Okay, so I hope you have done that. Let's move on to the question then. Okay, so question 7 asks, the body of same as rule in line 2 is what? Okay, so basically you have to fill in this blank. Okay, this line 2, the line 2 blank, what you will be filling over here is what you have to select from among these options. So which of the following do you think would be the definition of same as? Maybe I'll show you the data once more.
So it's option B.
Option B. Okay. Okay. So it's a pretty easy explanation if we just think about it practically. Since it's a definition of same as, it has to be a same as operation, right? So if we just go by that logic, it seems to be correct, but we also should check whether the definition is actually satisfied. So the first line of same as says that if we have two empty lists, then these two would be same. So this will output true. And then same as A and AS, which is basically heads and tails notation once more. These two lists would be same if AS and BS, which is the tail part of these two lists, will be same, right? Which is what the option said. Right. So this does make sense. Okay. Okay. Any confusion about this particular question? Okay. Thanks, Gurdeep. Thanks, Sivasami as well for the thumbs up. Let's move on to the 8th question now. The body of prefix of rule in line 4 is what? Okay. So now you have to fill in this line 4. Okay, so what do you think will be filled up over here? You can think for a while about it while I'll just quickly have some water. Okay, I'll be back. All right. Sorry about that. All right. So I'm back and I've also launched a poll where you can share your votes about which option do you think would correct. I'll just show the options also once more. Okay, we have one vote for option A. Does everyone also agree? Okay, so we have two votes for option A. And as we will see, option A is in fact correct because if we look at the definition, so the first line of prefix of says that the empty list is a prefix of every sublist. Okay, that makes sense. And then this AAS is a prefix of this ABS if the tail parts also satisfy the prefix condition. Okay. Sorry about that. I think I might have gotten disconnected for a while. Am I audible now? Okay,
Yes, sir.
okay. So, okay, we have another vote for option A. Let me just quickly demonstrate at once. Alright, so let's take the example that was given to us, which is prefix of. Okay, I'm not writing the whole thing, just the prefix of 1. So 1 comma 2 is the prefix of 1, 2, C, T, 5. Okay, this is what we want to evaluate. And what the definition says that this 1 comma 2 will be a prefix of this if two is a prefix of 2 comma C comma T comma 5. Okay. So here this was the A, this was AS, here this was A, and this whole thing was BS, and here what we have is AS and BS. And if we again go recursively, this will have 2 will be a prefix of 2 comma C comma D comma 5 if this empty list is a prefix of C comma D comma 5, right, which we know is true based on our base case that we gave. So that will be evaluated to true again, and if so this will be true, this will go back to this will be true, and hence this will output true. Okay, so option A is in fact the correct answer. Any doubts about this particular definition of prefix of? Okay, thanks, Somil. Okay, so A is the correct option as we saw. If there are no further doubts, let's move on to the 9th question. Okay, here we are asked the suffix of option. Okay, so we have to fill in line 5. The options are the same, prefix of same as suffix of sublist and subsequence. And I'll quickly shift to the data once more. So here you have to fill in the blanks in line 5. Okay, so what do you think will be the correct answer? Should I go to the options once more? Okay, maybe I'll quickly go through the options once more. So these are the options that are given to you. You have to fill in the first line of suffix as suffix of definition, and your options are you could fill it with prefix of as comma bs, same as as comma bs, suffix of as comma bs, sublist as comma bs, and subsequence as comma bs. Okay, these are your options. Which of these do you think would be the correct substitute for this blank in line 5? Okay, I'll give you some time to go through the code and then you can share your thoughts.
So can you go to the options?
Sure, sure. Yeah, so these are your options.
I think C will be the answer.
Okay, so we have one vote for option C.
Am I audible clearly or is it breaking still my
It's much
voice?
clearer now, Vineet. Thanks for changing the
Oh,
system. Right. Yeah.
okay.
What about the others? What do you think would be correct? I'll do one thing. I'll write down the data or the definition in the Jamboard, and then we don't have to keep shifting between the two options. Okay. So this asks us suffix of as comma bs if, and this is a blank that is given to us, and the second line says suffix of as bs if suffix of as comma bs. Not writing the whole thing. Okay, so remember here you have to uh, fill in the blanks in the first line of the definition, right? So in the previous two questions you had to fill in the blank, and the blank was there in the second line of the definition over here, but here this is given to you, you have to fill in the first line. So if you think about it, you can't fill it with option C, because option C was, let me go back to the options. Option C was suffix of as comma bs, right? So if you substitute suffix of as comma bs over here as well, it won't work, because if you are just outputting, this is the same thing, right? So you're saying suffix of as is a suffix of bs if as is a suffix of bs, but this is a cyclic definition, right? So Prolog won't be able to comprehend this. So was it clear, Vineet, why C can't be the correct option?
Yes, I thought we should fill the blank in the
Ah,
second line on this time too.
okay,
So I didn't see clearly
okay,
the
sure,
question.
sure. So think about it. So this is basically a base case, okay? So if we go back to the example that was given to us, so we had to check whether t comma 5 is a suffix of this bigger list, which is 1 comma 2 comma c comma t comma 5. Okay. What the second line will do is it will keep on removing one element from the front of the bigger list. Okay. So we have as, then b, bs. The as is a sublet is a suffix of this whole thing if as is a suffix of just the tail part, right? Which basically says that d comma 5 is a suffix of 1 comma 2 comma c comma t comma 5 if t comma 5 is also a suffix of 2 comma c comma t comma 5. Similarly, t comma 5 is a suffix of this whole thing if it is also a suffix of c comma t comma 5, and t comma 5 is also a suffix of this whole thing if it is also a suffix of t comma 5. Okay, so here you have reached kind of a base condition where if it actually is a suffix, then you have the same things, right, on both as and bs. So that is a hint. uh,
So it has to be
yeah,
equal.
so that would be same as, right?
Yes.
Yeah. So if we have this, then we have correctly defined suffix of, right? Any confusion about this question? Anyone? Okay, thanks for the thumbs up. All right, so I'm assuming there's no further doubts. Uh, Thanks again for the thumbs up. Let's then move on to the 10th question, which asks us about the sublist predicate. Okay, so here we have, so the options remain the same. Okay, we have to fill in line 7 of the data. Let me shift to the data once more. Okay, so here once more, remember you have to fill in the first line of the definition of sublist. Okay, line 7 blank you have to fill in with an appropriate option, and you have to define a sublist. Okay, so which option do you think would be correct? I'll give you a minute to think about it and then we can discuss it. Okay, so we have one vote for option A, which said prefix of. Uh, so Mr. Kamlakar says that prefix, so this blank should be filled in with prefix of AS comma BS. Okay. What about the others? Do we have any conflicting answers, or does everyone agree? Okay, so I think everyone agrees, and this is in fact the correct answer. So thanks for the answer, and let us shift to the Jamboard for discussion once more. Okay, so we have sublist of, I'm not writing the whole thing once more. We have sublist of AS comma BS. If then we had a blank, and then we had sublist of AAS and BBS. If sublist of AAS and BS. All right. So if we consider the option that was example that was given to us, we wanted to find out whether 2 comma C is a sublist of 1 comma 2 comma C comma T comma 5. Has to be a full stop here. So once again, look at what the second line of the definition was doing. So we are saying that this A comma AS, okay, so here 2 is A, C is AS, and here 1 is A, and this whole thing is BS. So we are saying that 2 comma C is a sublist of this whole thing if this whole thing A comma AS 2 comma C is a sublist of this bigger list without the head, right? If it is a sublist of 2 comma C comma T comma 5. So does this give a hint of which problem it gets reduced to? So if we are able to say that 2 comma C is the prefix of 2 comma C comma D comma 5, we have satisfied the definition, right? So if we just fill this in with prefix of AS comma BS, then this will check whether 2 comma C is a prefix of this thing, and it will turn out to be true because 2 comma C is in fact a prefix, and our sublist definition would also be correct, right? So option A is in fact the correct option. Any doubts about this particular question? Any confusion? Okay, so I'm assuming that there are no doubts, and that's great. Um, okay, so by the way, so the way we are discussing these options is one way to go about discussing these kind of questions. Of course, you can always verify it using Prolog itself, and I would actually encourage you to, when we close this session or whenever you are free, you can just type out the whole program, okay, in the Prolog, and then you can see by using different options for the blanks, what kind of differences are you seeing, whether the answers are correct and why are they incorrect if you use the wrong option, okay, and that will actually help your understanding. You can use the trace functionality that Prolog provides, and you can see where exactly the error is happening in the definition if you use the correct or if you use an incorrect option, or why it is correct when you're using the correct option. Okay, but we are discussing it kind of in a manual way because, yeah, I don't think when you when you write the actual exam for this course, you will have access to Prolog. So at that time, if you are given a similar question, you can solve it manually as well. All right, so okay, thanks again, Somil. Uh, let's move on to the 11th question, which is the last question based on the data that we had. So here we have to fill in the definition for subsequence, which is the blank in line 10. Okay, and the options again remain the same. Let's, yeah, was there a doubt? All right, so yeah, here you have the subsequence definition.
So it's option E.
Option E. Okay. So thanks, Sivasami. So we already have an answer. Uh, option E was subsequence, right? Okay.
Yes, sir.
Okay. So what do the others think? Does everyone also agree? Okay. We have another vote for option E. And since we are at a bit of shortage of time, I'll quickly go through the answer also. Uh, so option E is in fact the correct answer if you look at the definition. So the first line says that an empty list is a subsequence of any list, which is fine, which makes sense. Then the second line says that subsequence, so AAS is a subsequence of ABS if it would make sense if AS is also a subsequence of BS, right? So that is the correct option. So the blank will be filled in by subsequence of AS comma BS, right? And then the third line checks that subsequence of uh, AAS is a subsequence of BBS if AAS is a subsequence of BS. So here we are checking two different ways in which subsequences could be occurring. So if I just go to the options, subsequence would in fact be the correct option. Right. So if you remember, subsequence doesn't necessarily have to be a contiguous block, right? You just need to have the elements in the bigger list in the correct relative order, right? So that is satisfied if we substitute the blank with this subsequence AS comma BS definition. Okay. Um, I hope that is clear to everyone. If not, please let me know. Okay, that's great. In that case, let's move on to the last question of the session, which is, or maybe the second last, I'm not sure, we'll see. Um, so here we are given built-in predicate. So we have to use a built-in predicate append. Okay, so first of all, are you familiar with the append predicate in Prolog? Okay, that's great. So basically what the append does is, so you have three arguments x, y, and z, and you basically append x and y, and that is the output, which is z. Okay, so list all the solutions to the query. So suppose you are giving this as an, you're asking Prolog this particular question, append x comma y such that you get the following output. Okay, so you want to know what are the two possible lists that you could append to get this particular bigger list, which is 20220228. Okay, so how many such pairs of pairs of x and y's do you think could exist?
So can we run the specific code on the Prolog software
Yeah,
itself?
you can do that, and it will be outputting the different possible configurations. So let me show you that in practice.
So, okay, so I try to work on with it, but I don't know what's the error I'm getting. So I'm not getting output, it's just stuck. That's why I'm asking this.
Okay, let's see. Let me just share my entire screen. Alright, so I hope the Prolog screen is visible.
Yes, sir, it's
Okay,
visible.
so let's see what append outputs. Okay, so we have x comma y, and we want this list. I just have to quickly check what the list was. So we have 2022 and then 0228. This was the question, right? Okay,
Yes,
so
sir.
we press enter, and this is one possible output that Prolog has given us, okay, which is basically x could be an empty list and y could be the whole list itself, right? And when we append this, which is basically we add whatever is in y to the back of x, we will get the output, which is the whole list, right? You agree with me?
Yes,
Okay,
sir.
so Shivasami, is this where your program is stuck?
Not exactly, sir. It didn't even run. I don't know what's the error test, but it's just stuck when I give enter.
Uh, okay, did you make sure to put the full stop at the end of the query?
Yes, sir, I did.
Okay, what exactly is the error that is occurring for you? Does it say something?
After when I give enter, sir.
Okay, does it?
So I'll just try again. I'll let you know just in a
Sure.
second, sir.
X and Y should be uppercase because prologue it takes variables in
Yeah, rightly
uppercase.
pointed out.
Probably
Yeah,
that could be.
rightly pointed out. You have to make sure that x and y are capitalized because they have to be variables. Okay, so this was one possible configuration, right? So if you want more such configurations, what you can do is uh, press the semicolon key. Okay, so if you press the semicolon, you'll get another possible configuration, which could be that x is 2 and then y is 022 0228. And if you append these two, again you'll get the same list, right?
Yes, in total 9
Exactly,
configuration.
there will be 9 such configurations. So if you keep inputting the semicolons, ultimately you'll arrive at this last configuration where x is the whole list and y is an empty list. And again, if you append all these, you'll still get the whole output correctly. And now after putting semicolon, which it says false, which means that no more such configurations are possible. So these are all the configurations, which are basically 9 such configurations. Okay, so this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, and 9. Okay, so I hope that was clear.
Yes, sir.
Okay, I hope your issue was also resolved, Sivasami.
Ah, yes, sir. I just misplaced a comma with a
Okay,
full stop.
okay, let me just share the screen once more. Okay, yeah, so 9 is the answer. Okay, let's just look at the last question now. So turns out this wasn't the last question. We have one more question remaining. Uh, and this is kind of a recall based question. So we have to select the correct options, and the options are, uh, can all first order logic formulas be expressed as Horn clauses? Is the SLT resolution always terminating with a solution or proof? Does the SLT resolution always terminate, or are none of the above options correct? So what do you think is the correct answer?
It's none of the above, sir.
Yeah, that is right. None of the above options are correct. Thanks, Yosami. And that is because so all FOL formulas cannot be expressed as Horn clauses because Horn clause needs to have at most one positive literal, right? But FOL formulas can have more than one positive literals as well. Okay, so option A is incorrect. Then SLT resolution does not always terminate with a solution or proof. If there isn't a proof, then it will not terminate, right? So based on that, both options B and C are incorrect, and the only option that we are left with is D, which is that none of the above are correct. Okay, so this was straight from the lecture, so I hope this is clear to all. And that brings us to an end of today's session. So we uh, consumed almost all of the 2 hours that we had, and yeah, so if there are no further doubts, we can end the session.
Sir, can I
Yeah,
ask you
sure,
one
sure.
question? Okay, I'm trying to solve one of the previous year
Okay.
question in using the
Uh-huh.
trace option, but it says there is a syntax error. I'm posting the code and in the chat
Okay.
box. Did you get that?
Uh-huh. Yeah, I can see it.
I'm seeing only the last line. Did you get the entire code or only the
Uh,
trace?
so the first line is likes A, B, Y, and X, right?
Yeah, right, right. When I'm trying to see how the solution is proceeding by using the trace
Okay.
command. It was saying there is a syntax error after trace. I do not understand how to fix that.
Okay. I see that you've also used a cut operator, is it?
Yeah, cut operator is also used. I removed that cut operator
Okay.
also, but the code is not, it's always saying there is a syntax error after trace. Whereas if I remove that trace and ask it only likes, comma, ab, comma, m, it says true. When I put both, it is saying false. But when I ask it to use the trace, it is saying syntax error. I had success of using a trace with on other stuff, but I don't know why on predicates it is giving an error.
Okay. Um, so I'll also have to revise my uh, understanding of trace. So maybe I'll
Okay,
copy this question and I'll try it out myself. And then,
I posted those questions in
okay,
discussion
yeah,
group. The cut operator ones are really I'm not able to understand how to solve
yeah.
them.
So I think you'll cut operator will be dealt with in the next week 7, right? So
Oh,
yeah, I think
okay. I thought it was this year's this week's
No,
portion.
no.
Sorry.
So you will have, I think if I remember correctly, there will be a separate video on the cut operator in week 7. Uh,
Okay, sir.
but
Okay.
anyway, I'll also try to solve this at my end, and then I'll either post it in the discussion forum if I am able to come up with any solution, or in the next live session also I can take it up once more.
Okay, sir. Yeah.
Okay. Okay.
Thanks, sir.
I'll just save this particular question. Okay, I have done that. And all right. So if there are no further doubts, also it's all, yeah.
I do have a doubt. So in the following like week 6, we are given a program and we are asked to find some things. So to do that, we have to save the program file as a prolog source code, right?
Dot
Like
.pl, yeah.
.pl. Yes. Once after doing that, when I try to give the given queries, it's saying incorrect goal, or it says like this goal cannot be supposed to be verified, or DWIM could not be the correct goal. This is the error which I am getting. So
Okay. Is it getting saved correctly?
yes, I have saved it twice and it says no need to save further again. No changes
Okay.
need saving. Even after that, when I give the query, it's saying it could not be the correct goal.
Okay. Um, I'm not sure why that might be happening, because I'm also unaware of the question. Uh,
Sorry to
yeah.
interrupt. I am using the online
Okay.
compiler, so I don't have to save it with any uh, .py or something. Uh, online Swish compiler.
Okay. I think Sevasam is talking about the downloaded and installed version on the
Yeah,
PC.
right, right. I understand.
So that's why he might.
Even if I'm using online, how can I tell the compiler that I'm running this particular code right over
Yeah,
there?
even I don't know. So I haven't
If you
used the
go
online version of Prolog much. I usually use the desktop version only. Um,
on online, if you go to that Swish one, you click on program. It will ask you to paste your code there,
okay.
and then you enter your whatever query in the output window.
Okay,
Okay.
okay, thank
Yeah.
you.
So thanks, Mr. Kamlakar. So maybe you can try
Okay.
that Sivasami and see if it resolves it. Uh,
Sure, sir.
Otherwise, I'll see if I can find something on it. Can you just repeat what was the issue that you were saying? No goal, is it?
Yeah, it's saying this could not be the correct
Okay.
goal. So it even gives one a code like DWIM followed by could not be the correct code.
Okay. So what you can do is you can search in the search on Google about. So usually there will be communities that may or may not have encountered similar errors. You can search this error and see why this might be happening. If there are some already existing
Okay,
answers, I'll also try to find something on it, and if I can, I'll post it in the discussion forum. Okay.
okay, okay. Thank you, sir.
Okay. Uh, Thanks for the questions, by the way, Shivasami and Kamalakar as well. Uh, so we are already past 8, so let's close the session for today. And thanks all for attending, and we'll meet next week.
Thank you,
Thank
sir.